Hello, you absolute legends. This is supposed to be an IV bag that's, say, hanging from a stand in a hospital. You know, one that you'd sit next to when you're donating blood or you might be in the hospital. And these IV bags, they have a volume of about 250 milliliters of just saline solution just in there. A nurse injects inside of the bag via port. I'm just going to draw it straight in there. She injects a solution that is 50 milliliters, and it contains, it is 0.5 moles per liter of what's called heparin. Ooh, I hope I spelled that right. It's what's called heparin, and it's an anticoagulant drug. So, for example, if somebody has a blood clot, or if they are, excuse me, not even a blood clot. Like, say you have long-term, if you're in a hospital and you're in bed and you're bedridden for a long time, there's a possibility of blood clots because your blood is not flowing because you're not moving and the muscles aren't contracting. So maybe you would be prescribed heparin by a doctor to help prevent blood clots, which could be a bigger issue down the road here. When the nurse injects the 50 milliliters into the 250 milliliters, the total volume is 300 milliliters. 50 plus 25. Nothing crazy. Just imagine you injected the syringe in there. The bag's going to fill up a little bit. Okay? Now, the heparin inside of the syringe, which I'm going to represent with some red dots, okay, that's the concentration of the heparin inside the syringe. Then when it's pumped into the IV bag, that heparin is diluted inside of the IV bag. What is the concentration inside of the IV bag? The pictures that I have drawn here are meant to help your atomic vision of what happens when something is diluted. When these molecules are inserted, they spread further apart, they spread further out, and they are diluted. So we know that this final answer will be less than we know that our final answer will be less than 0.5 moles per liter because it's got to be. We diluted it by injecting it into a larger volume here. Not much less, though. There's a ratio that really rolls off the tongue. It's pretty melodious. It's called M1V1 equals M2V2. M1V1, M2V2. This is a formula where you plug in the moles, the molarity and the volume in the beginning. And here are the concentration and the volume of the end. So this is like a start-finish type problem. That's how I refer to it. The start-finish. I-N-I-S-H. I think I spelled that right. We know the initial molarity. We know the initial volume. The initial molarity is 0.5 moles per liter, and the initial volume is 50 milliliters. Bada bing. The finish at the end of the day, that's what we're solving for, is M2. So we're just going to put that in there as M2. You can also put it in there as X or a question mark, because that's what you're going to solve for right there. The volume, pause. This is the curveball of the trick. Remember, it's the total volume at the finish. 250 plus 50. Bing. Really just multiply and divide out. 25 divided by 300. 1/6. Not 1/6. 0.08 moles per liter is the concentration of heparin in the IV bag. I have no idea if that's a therapeutic concentration or not. I hope that's not dangerously high or dangerously low, but that's what it is. I hope this helps. Thank you.